Hey guys, hope everybody's doing okay. What we're going to do right now is take a look at an extension of the first lesson on ICEE tables. All right. So in class we should have had an introductory lesson on ICEE tables and how to set them up and how to get the overall process going here. There is one type of ICEE table problem where it involves a little bit more math, or actually a lot more math, and we'll get into that right now. I'll show you how to do that. It's really just a math problem once you get it set up, but it is a little bit different than some of the ones we did in class, the last time we were in class. I want to make sure we know how to do those before we go into another day of practice and doing more of these ICEE table problems. So this is in your packet, all right? You have equilibrium system, CO plus H2O yields CO2 plus H2. So it gives you a whole bunch of information here for the problem. On the next slide I have that set up for you. But what you're going to end up finding out here is that at equilibrium, you don't have any equilibrium values given to you. All right. So that part of our ICEE table for equilibrium, the ones we've done already have at least given us something to work with there. Here, you're going to end up with all variables. If that's the case, but you're given the KEQ value, which you are right here, okay, it's 1.56, you're going to have to do something called a quadratic equation. All right. So I'm sure everybody's thrilled about this. Here's what it is. You can write it down. All right, so it's x equals negative b plus or minus square root of b squared minus 4ac over 2a. All right, so let's take a look at how we go about this. Give you a second to set up your ICEE table. All right, the same problem as the previous slide. All right, so you have your initial, your change, your equilibrium equation, and your equilibrium value. So let's go ahead and put our initials in. Now we have 500 mils of stuff here. Like it's a 500 milliliter flask. So we're given moles. You know that we're dealing with KEQ, and that is with concentration. So I already went through and did the math for us, but for carbon monoxide, you had 1 mole of CO in a half a liter. So 1 mole over 0.5 liters gives you the 2 molar CO. Water, it's 1, and then CO2 and H2 are 0. Okay. The 900 Kelvin is just telling us that we have our specific temperature for this. So our KEQ value of 1.56 is only good for that temperature. Now, here's our arrow there. We only have reactants. So this is really easy because we have to go to the product side. There are no products here. At equilibrium, we need something on both sides of the equation, right? So we're going to have negative x for CO, negative x for H2O. We're going to have plus x for CO2 and plus x for H2. All right. That's pretty simple, right? Talked about that the other day. So we have reactant and no product. We have to shift forward. So equilibrium equation, we have 2.00 minus x, 1 minus x, x, and x. Okay, so we have our KEQ value, right? It's 1.56. But I don't have anything else, right? I have all of my equilibrium equations here, but they all have x in them. There's not one of them where I don't have that variable. So let's go through the process of how we use the quadratic formula to solve this. And you guys will try one, and that'll take care of the lesson for today. All right, so the next slide is just blank. Here's how we'll go through the work. And if you know how to do the quadratic already, you can figure it out, and fine. It's good to go. I'll give you a shortcut, or I'll tell you about a shortcut at the end. Let's just do one without doing the shortcut way. All right. So my KEQ expression, I'm going to write it out. Okay. So it is products over reactants. So it's going to be x times x over my reactants, which are here. Okay. So the next slide doesn't have this chart, so I need more room. So you just use your notes to see how it gets filled in. So we have x over 2.00 minus x times 1.00 minus x. Okay. So I'm going to try to simplify a little bit of this. I have my KEQ value, that is 1.56 equals x squared over, now I need to factor this or whatever, that 2.00 minus x and the 1.00 minus x. That's going to give me 2.00, I have to use the FOIL method, I think it's what it's called. I don't know if they still call it the FOIL method, but that's what it was when I was learning how to do it. So you have 2.00 minus 3x plus x squared. Okay, so you do the, you do your 2.00 times 1.00 gives you the 2. You have minus 2x minus 1x gives us minus 3x. And negative x is x squared. So that's what we have. Okay, I've got to simplify all this stuff. So I'm going to cross multiply. I'm going to take the 1.56, multiply it by this whole thing. Okay, and what we're going to end up with is 3.12 minus 3.12 minus 4.68x plus 1.56x squared equals x squared. Okay, so I did 1.56 times 2, 1.56 times negative 3, and then 1.56 times the x squared there. This is what I get. I need to simplify this even more because I need to have it in the form of, x squared plus something x plus something, right? So I'm just going to bring all of this stuff over to the right. Okay, I'm going to bring all this over to the right. So I end up with a positive x squared value, all right? So, I have, actually what I could do is, it's a lie, and bring it all over to the left. Okay, sorry about that. I'm going to take the x squared, just bring it over here. So subtract x squared from both sides, and we're good to go. So 1.56 x squared minus x squared gives me just 0.56 x squared minus 4.68x plus 3.12 equals 0. Okay, I just needed to reformat it in the x squared plus something x plus something equals 0 format, right? So that's why I ended up with, if I brought my 1.56 x squared over to the right and I subtracted by that, I'd have a negative x squared, which is just a mess. So I just like to keep that positive if I can. So I just realized I should bring the x squared over here because 1.56 x squared minus 1x squared is just 0.56 x squared. Okay, so the 0.56, that's your A. The negative 4.68 is your B, and the 3.12 is your C for your quadratic equation. So it's negative B plus or minus square root of B squared minus 4AC over 2A. Okay, plug your numbers in. Okay, so plug in your A, B, and C from above, and you end up with this. You get 4.68 plus or minus square root of 21.9 minus 7.00 over 1.12. All right. What you end up with, is, go down here, I guess. You have 4.68 plus or minus 3.86. So I just take the square root of this over 1.12. All right, math it out. You have two answers here because it's the plus or minus 3.86, right? So you end up with 7.63 or 0.732. Okay? If you go back here, the 7.63, does that make sense? Well, it would make sense over here. You get 7.63, 7.63. You're like, okay, let me go to the other side. 1 minus x. 1 minus 7.63 is negative 6.63. Well, I can't have a negative equilibrium value. Okay, so that's no good. So that's how I know I'm getting rid of this answer, right? It makes no sense to have that answer be correct. So my answer for x is 0.732 molar. All right, so if I go to my table, all right, I had all the other stuff here. Okay, all the other stuff was already filled in. This was 2 minus x. All right, so 2 minus 0.732 gives me 1.268. This was 1 minus x. So 1 minus 0.732 gives me 0.268. And the other ones are obviously 0.732 and 0.732 because these were x and x. All right. Yeah, and this was 2, 1, 0, 0 minus x plus x plus x. You already had that. Okay, so you can see your equilibrium values for everything, for all four things. So is it a lot of fun? Not really, unless you enjoy the quadratic equation. Maybe some people do. But that's how you want to approach problems like this. You are not going to have to do this a ton in the course, but it's something that is important that you know how to do. I'll talk more about this in class about what the College Board expects if you were to do a quadratic or not on the College Board exam. But if you're taking a chem class in college, there's a great chance you're going to have to use the quadratic to solve some sort of equilibrium ICEE table. So that's why I'm talking about it and going over it here. So your turn. There's one more on your note sheet. Okay, so give it a try. I'll help you get it set up here, and then we'll go from there. So you'll end up doing the something similar for a problem like this. So you have CO2 plus H2O yields CO2 plus H2. So let's set up our ICEE table here. So we have CO plus H2O equilibrium, CO2 plus H2. Okay, so ICEE table. Okay, we're at a 125 milliliter flask, so that's 0.125 liters. All right, so we have to figure out what our molarities are. So for carbon monoxide, you have 0.250 molar, so 2.250 moles over 0.125 liters, and that's going to give you 2.00 molar. Okay, the water is the same thing, 2.00 molar because it's 0.250 moles of it, and then we have nothing here. Okay, the reaction has to go to the right because there are no products, so we're going to have minus x plus x plus x. Okay, your change is right there. Your equilibrium equation is 2.00 minus x, 2.00 minus x, x, and x. All right, same situation we have as before. So we have all of our values here with a variable in it. So we need to figure out how to do the quadratic. Or if you're smart about your math, you could take a little shortcut here. See if you can figure that out. Pause the video. If you're in Edpuzzle, I'll have it pause for you. Try to knock it out and see if we can actually get an answer. All right, let's see how we do, and we'll go over it and go from there. Let's see how we did. I'm going to go to a blank slide here and work it out this way. So if you did the quadratic, that's fine. You could have done it here, but and students always want to jump right into that because now they try to use it for everything. But let's just go back to the basics here real quick. Let's write our KEQ expression. So the KEQ value is 1.56. So we end up with 1.56 equals x times x over 2.00 minus x times 2.00 minus x. Okay, so what you can do is like we did last time, you could put x squared on the top, right? And then you could use the FOIL method down here in the denominator and work that out. But if you slow down a second, you could realize that there's a massive shortcut you can take here. So you have 1.56 equals, the numerator, x times x, is x squared, right? Well, look at your denominator. It's 2.00 minus x times 2.00 minus x. What you can do is just do 2.00 minus x, 2.00 minus x squared, right? This is super sloppy, I'm so sorry. You get the idea. 2.00 minus x squared. That quantity squared, okay? So what you can do then to simplify that is super easy. You could take the square root of the entire thing. Take the square root of 1.56. Take the square root of x squared, and you'll get just x, right? What's the square root of 2.00 minus x, that quantity squared? Well, the square root undoes that square, so you just end up with 2.00 minus x in your denominator. And the square root of 1.56 is 1.25. All right, look how easy that is. All right, so you could have done the quadratic and knocked out all that, right, and go through that big grind and probably make a silly math mistake somewhere along the line, or it's a really, really easy calculator error or just addition or subtraction error. Or you could just think a little bit and say, all right, I could do the square root of everything here, square root the whole thing, because everything I have in my fraction, my numerator and denominator, is a square. You couldn't do it here in this one. Okay, way back when here, because in your denominator you didn't have the same thing squared. You had 2 minus x times 1 minus x, right? So you couldn't just you couldn't simplify this denominator here to say something quantity squared, because the quantities were different, right? Here it was the same. So solve for x. So bring this, up here. So you make 1.25 times 2 minus 1.25x. All right, simplify it all, and you end up with x equals 1.11. Okay, if you just do simple algebra, right? So you have 1.25 times 2.00. Minus 1.25x equals x. Right? Then you plug it in your calculator. Well, you don't need to. 1.25 times 2 is pretty easy to do without a calculator. Get x over here, get x over here and just solve for it, right? You end up with 1.11 for x. So you go back to your table and your final stuff here, your final equilibrium values, 1.11, 1.11, right? 2.00 minus 1.11 is 0.89, and same thing, 0.89. So those are your values. All right, so we want to know specifically the concentration of each reactant. Each reactant is 0.89 molar for a situation like this. All right, that's really about it, guys. All right, guys, so to wrap all this up here, you can see I just tried to finish it for you down here at the bottom. So you have 2.50 equals 2.25x. Divide both sides by 2.25. You get x equals 1.11. College Board is not going to ask you to do a quadratic on the College Board exam, but exams in my class, you might see a quadratic on there, and you'll definitely will in some of the homework. So what you will probably see something more like is what I have on the screen right here, where you could do the quadratic and waste a lot of time. Or you could take, you recognize that algebra, okay, and make that shortcut right here, all right, where you square root everything, and then you could get right to your answer where it is. Here's my recommendation to you as I wrap up this relatively short lesson here. Since the College Board won't ask you to do a quadratic, and on the tests I give you, you're not going to have to do a quadratic. For the homework problems that involve a quadratic, I want you to know how to do those, okay? I want you to know how to do the algebra and get the x squared, x, and your equations the right way. But what I would do to save time, if you are pretty good at the algebra, if you could knock out the quadratic and plug things in the right way, on your calculator, if you have a graphing calculator, program it or find somebody that knows how to program, or just Google it. I have students every year just Google the answer. Figure out how to make a quadratic program in your calculator, where you literally would do the math on your paper, okay, and you would get to this point right here. Let me go back. All right, you'd get to this point right here, okay. You'd set up this equation, okay. Then in your calculator, all you have to do is type in A, B, and C, and it tells you the answer, okay. So I would definitely invest some time in doing that. A few minute investment in time will save you a ton of time down the road. If you don't know how to do that, or you screw it up or something, just go to Google and type in quadratic equation solver, okay? Find the first link. That's what I use sometimes if I don't want to go through the whole math. And then again, you'll just go to that link, type in 0.56 for A, negative 4.68 for B, 3.12 for C, and it'll spit out these two answers for you. All right. they'll save you a ton of time. So just a recommendation for you if you notice that there's more quadratics and you would like to solve on the homework. Quadratic solver in your calculator. Some of the newer calculators might have it in there already. Just see if you can find it. Older ones, you have to program it in, but if you go to Google, it tells you how to do it. And then finally, if worse comes to worse, go to Google, type in quadratic formula solver, find a website, and you can do it that way. Okay, it'll save you some time down the road and make your life a little bit easier. But make sure you know how to at least go through the process once, once or twice in your homework, in your notes. It will be good to go. Okay, there's a little bit more ICEE table practice, but we should have one more in-class day to work on that and do some practice. If you need any help, make sure you talk to me and let me know. All right, guys, that takes care of it. Thanks.